Ever wonder how self-driving cars learn to navigate bustling streets? It's not just about coding rules, it's about simulating real traffic over time. But here's the problem. Most traffic simulators struggle when cars enter and exit the scene, leaving empty roads that look totally unrealistic. Today, we're diving into a breakthrough called InfGen, a model that keeps traffic flowing like a real-life movie, even when the action moves far beyond the starting frame. Let's start with the core challenge. Traditional simulators focus on short-term motion, like predicting where a car will go in the next few seconds. But self-driving systems need to plan for minutes, not just seconds. The issue? As the car drives, new roads appear, old agents vanish, and the scene becomes a ghost town. Imagine a movie where characters randomly disappear. That's what current models do to traffic. Enter InfGen. This model doesn't just predict motion, it generates the scene itself. Think of it as a storyteller who dynamically adds new characters and removes old ones, keeping the plot believable. InfGen switches between two tasks: motion simulation, figuring out where cars go, and scene generation, spawning new agents where needed. It's like having a director who ensures every scene stays packed with life, even as the story moves to new locations. How does it work? InfGen uses a transformer model, kind of like an AI that reads traffic data as a sequence of clues. It converts motion and scene data into discrete tokens, like puzzle pieces. Then it interleaves these tokens, deciding when to focus on movement and when to refresh the environment. This allows it to handle 30-second simulations, 6x longer than previous models, without losing realism. Here's the clever trick. InfGen uses autoregressive prediction, like writing a story, one sentence at a time. The AI generates traffic scenes by predicting tokens, which are data units representing things like a car's position, direction, or whether a pedestrian should cross the street. It builds scenes step by step, scaling up smoothly even as the road gets busier. But how does it know what to focus on? Researchers used a masking system, a filter that says, pay attention to this, ignore that. When adding a new car, the model only looks at past traffic data, not future movements it hasn't generated yet. This causal attention ensures the simulation stays logical, like a storyteller who doesn't skip ahead. They also tackled a big hurdle: class imbalance. Some actions, like adding a new agent, are rare compared to regular movements. To fix this, they gave different weights to these events. Adding an agent gets a 0.1 score, while motion updates get 0.9, like a priority system so the model doesn't ignore rare but critical events. The proof is in the pudding. InfGen outperforms all existing methods in long-term simulations, keeping traffic dense and realistic. Metrics like placement accuracy, how well agents are positioned, and kinematic consistency, smooth movement, show a slower decline over time. This means InfGen's scenes stay believable longer, even as new agents pop into existence. But it's not perfect. The model sometimes adds unrealistic agents, like cars stuck on road edges, or fails to predict their initial movements. These failure cases highlight areas for improvement, like refining fine-grained control or handling flickering agents, those that appear and disappear abruptly. Researchers are now exploring ways to improve long-context understanding and integrate map generation for even more expansive simulations. This isn't just a technical win, it's a step toward safer, more reliable self-driving systems. By solving the long-term simulation puzzle, InfGen brings us closer to training AI that truly understands the chaos of real traffic. Next time you see a self-driving car, remember, behind the scenes, models like InfGen are making sure the road never feels empty. Thanks for watching. If you want to see how this tech shapes the future of mobility, hit subscribe. And drop a comment. What's your take on simulating real traffic? Let's keep the conversation going.